Hello everyone, welcome to math class. Today's lesson will seem very similar to yesterday's. We're taking the concept of equivalent fractions and we're going to move on with it, okay? So, using what we learned yesterday, let's review a little bit. Okay, first of all, when we have a fraction, let's say 3/4, we know what we need to refer to the top number as, right? We don't call it the number on the top, we call it the numerator, okay? And the number on the bottom, we call the denominator. So if you didn't forget, or if you did forget, I think of Notre Dame. Okay, the college. That has to go in order, Notre Dame. All right, so that's numerator and denominator. We can't forget that. All right. So yesterday, what we focused on a lot was figuring out how to make equivalent fractions with pictures. And then at the end of the lesson, I did show you a really cool trick. So we're going to work on both of those more today. So you should be on page, I believe it's one, actually I don't remember. Whatever the page said, I can't see it right now. You should be on this page with me. If not, pause, go get your math book, your instruction book. When I write on this book, you should be writing with me at home, okay? You should also have your whiteboard because you know sometimes I'll kind of go off to the side. We'll have to do some practice. So make sure you're prepared and we'll begin. All right, let's explore the idea. Dividing models is one way to think about equivalent fractions, okay? Just like we started yesterday. So we're going to walk through number 2 here. The model shows 1/4, right? One thing is shaded out of 4 possible, right? So the whole thing is split into 4, which our denominator says. One space is shaded. So how many equal parts make up the whole? So the whole thing, one circle, right? But how many parts has it been split into? 4. So it's been split into 4 equal parts. And then it says use a ruler to draw 2 more lines to make 8 equal parts. You can use a ruler if you want. That's the only way to be exact, but you can still do a pretty good job. So if you don't have a ruler, that's okay. So to divide this into 8 equal parts, basically I have a plus sign, right? If I want to make it into 8 parts instead of 4, I need to split all my pieces in half. So now it's like I'm making an X through my plus sign. So now it is split up into 8 equal parts. So number 3, it says compare the 4 equal parts to the 8 equal parts. All right, how many times as many parts are there now? Before we had 4 parts, now we have 8. So how many times as many do we have? 4 times what equals 8? 2. So we have 2 times as many, right? Now how many parts are shaded? Before we only had 1 part shaded. Now, since we split them all into 2 pieces, we have 2. Why are there 2 times as many parts shaded as there were in the 1/4 model? Well, remember yesterday I told you when your denominator at the bottom of your number gets larger, it means your shape is being split up into smaller pieces, right? So the more pieces we split our shape into, the smaller each part will be. So let's read this again. Why are there 2 times as many parts shaded as there were in the 1/4 model? Because we have 2 times as many parts, right? So we can say we split the model into 8 parts instead of 4. I will give you a minute to copy that down. And if you have different words that you would like to use, feel free. Okay, I am giving you one example. We could answer that question in many different ways. Okay, so then down here we've got number 4 and 5. And our directions tell us to use the model above to answer problems 4 and 5. So we're still going to be looking at our circle here, though we've now split into 8 equal parts. Number 4. If 3 of the original 4 parts were shaded, how many of the 8 parts would be shaded? Okay, so for comparison, why don't we go ahead, let's do your best, draw another circle next to the one we're looking at, and let's split this one back into 4 parts. So they said if 3 of the original 4 parts were shaded, so let's color in 3. How many of the 8 parts would be shaded? So if I had 3 of my quarters filled in, that'd be 3/4 shaded. Well, let's see on this one. We want to make our pictures look the same. Okay, that looks about right. I'm going to color that in so we can see it better. So now we have to count. Instead of having 3 spaces filled in, we have 1, 2, 3, 4, 5, 6, which makes sense, right? Since we split each of these in half, instead of each of them being 1 space, now they each have 2. So, how many of the 8 parts would be shaded? 6. There's only 2 spaces not shaded. And finally, number 5. If all 8 parts were shaded, how many of the original 4 parts would be shaded? Well, let's take a look. Here's my circle split into 8 pieces. I'm going to shade all of them in. If they're all shaded, it would be the same in both circles, right? They'd still both be all shaded. So if all 8 parts were shaded, how many of the original 4 parts would be shaded? All 4, right? And your line is down below. I can't see it. So 4 would be shaded. All right, I'm going to pause a minute to get the screen changed. Okay. So I just scrolled down my page. We're ready for number 6 and 7, so make sure you're ready in your book. Now we're going to try these 2 problems. All right, if this seems kind of hard, that's because this idea we're about to practice is a little hard. So just hang in there, okay? Hang in there with me. We are going to draw a model, okay, that means drawing a picture, to show 2/3, okay, so that sounds like our first step, and then divide it into a different number of parts to show an equivalent fraction. All right, just like with any word problem, you can mark up your important stuff. First, I'm going to put this in a circle so I don't forget. That's what I have to do first. And then divide it into a different number. That's second. But I have to show an equivalent fraction. Okay? So we've got a few jobs to do. First, we need to draw a model to show 2/3. So I am going to draw a rectangular model. These are usually easier for me to draw. You don't have to do it perfectly, just try to be as neat as you can. And we need to show 2/3. So when I'm trying to draw a fraction, my denominator tells me how many equal parts. So the 3 tells me I need to have 3 parts. So do your best to make them look close to even. And then we need to show 2/3 are shaded. So make sure you're neat. You don't have to fill in every part of your box, but make sure you're not scribbling outside the edges. So that shows 2/3, right? Okay. So I think we've got the first part done. I'm going to switch my marker color so you can see how I divide it into a different number. Okay, this is the part that might be tricky for some of you, so listen carefully. We need to divide this box into a different number of squares, just like we did our circle. So remember, it started with 4 spaces, and we changed it into having 8. So there's an easy way to do this. Anytime they want you to show with a picture, think about dividing all your spaces in half. Okay, let's try this. What if I drew lines like this to split up my shape into not 3 spaces, but now I have 1, 2, 3, 4, 5, 6. All right, you see what I did there? All I did was split each of my third sections in half. So now how many sections of my shape do I have? How many equal pieces? Now I have 6, right? Remember, the denominator just tells how many equal pieces. So I can count 1, 2, 3, 4, 5, 6. All right. Now, out of my 6 pieces, how many are shaded? All we have to do is look and count. 1, 2, 3, 4. So, let's see if we've answered our question. Draw a model to show 2/3. We did that first, right? And then divide it into a different number of parts to show an equivalent fraction. So we divided each of our pieces in half and broke our shape into 6 equal parts. And we realized that when we split them all in half, our numerator would be a 4 instead of a 2. So we can say that 2/3 is equivalent or equal to 4/6. They look different, but if you look at the picture, they're showing the same amount out of our whole shape, right? So they're equivalent. All right, let's look at number 7. This model shows 30 100ths, okay? So that's a big fraction. It means the same thing. Our denominator is 100, so we have 100 even spaces, and the numerator tells us that 30 are shaded in. If the model had only 10 equal parts, how many would be shaded? All right, well, let's not make this too hard, okay? Think about, when we look at this picture, does it almost look like we've got 10 rows that go across, 10 groups of 10? Yeah. So if I am saying this is one group instead of, oops, sorry, my line got a little wonky. Instead of saying this is 10 things, what if I just said this whole top row was 1? And then my second row was my second piece. And then 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it's kind of hard for you to see, but really my bars, here, I'll just draw a new picture. Instead of having all those little squares drawn in, I just have rows. Okay, I could keep drawing. But that's how we're going to think of it. So if we're just going to pretend, instead of 100 parts, it only has 10 equal parts. Okay, so my new denominator, instead of 100, is 10, because we're splitting it into 10 equal parts. All right? So if my denominator is 10, and I'm counting each row all the way across as 1, how many rows are shaded? 3 rows, right? So 3 rows out of my 10 rows have been shaded. So we can say that 30 100ths is equivalent to or equal to 3/10. Okay, it's just a different way of looking at the same fraction. All right, give me 1 minute to pause to get to my next page. Okay, so now we are on the last page, and up at the top it says to write the equivalent fractions from problems 2 and 3 on the page before. So I've already copied those over. So our equivalent fractions, we've realized that 1/4 is the same as 2/8. Okay, remember on our circle diagram, the first problem? So all I've done is copy those over. Multiply both the numerator and denominator of 1/4 by the same number to get 2/8. What number did you use? Why does this make sense? All right, so this is getting back into the trick I taught you yesterday. So go ahead, make sure you're writing with me. So we're going to put 1/4 up here. They say multiply both the numerator and denominator of 1/4 by the same number. So we're going to just say times something over something. We're going to figure out what goes there to get 2/8. Okay? Remember, there are 2 ways to find equivalent fractions. You can look at models, like the way we did to solve this, or there's a trick. We're going to review the trick. So we need to figure out what numbers have to go here in order to make this true. So let's break it apart. Just look at the numerator first. 1 times something will give me a 2. There's only one number that will work. I think we've all figured it out, right? 1 times 2 is 2. So we have to put a 2 there. Now, remember, what's the most important thing about this trick? Do you have to have the same number on the top and the bottom? You absolutely do. There is never a time to find an equivalent fraction where you can use a different numerator and denominator. They have to be the same. So if the 2 went in the top, the 2 also has to go in the bottom, but that makes sense. 4 times 2 is 8. So, on the earlier page, in order to figure out that 2/8 was equivalent to 1/4, we had to do the model, split it up, draw the picture, all of that. The trick, though, could I find the same equivalent fraction just by multiplying 1/4 by another fraction that has the same numerator and denominator? Yeah, we got the same answer. So what number did we use, and why does this make sense? All right, so we multiplied one-fourth by 2, because you can do B/C because we'll run out of room. We multiplied 1/4 by 2 because we needed to double our numbers, right? Our 1 needed to become a 2, and our 4 needed to become an 8. 2 was the only option that worked. So we multiplied 1/4 by 2 because it would cause the 1 to become a 2 and the 4 to become an 8, which was our goal. And now we can just talk about why does it make sense. Okay, we know it makes sense. Remember what I've told you. Anytime your denominator gets bigger, it means your pieces are getting smaller. Now let me show you that real quick with some visuals. Okay, so here's our one whole thing, right? It's a strip. If you can't read it, it just says 1. Now, if I split that in half, okay, that's about half that shape, right? So this fraction is 1/2. Denominator is a 2. What happens when I make that denominator a little bigger? Did my piece get smaller? Yeah. Let's make it even bigger. What about instead of a 4, if I had an 8? The piece keeps getting smaller. Okay, we can go even smaller than that. If I have 1/10 with a 10 in my denominator, the piece is even smaller. And the littlest pieces I've got are 12ths. So 1/12 is my smallest piece. So if you're noticing, the bigger the denominator, the smaller the piece. Okay, so make sure you remember that pattern. All right, let's slide this out of the way. And let's take a look at this one. What happens if you divide both the numerator and the denominator in 2/8 by 2? Let's check. Okay, let's write it with me. 2/8. We're going to divide both the numerator and the denominator by 2. Division by fractions works the same as multiplication. So you just look across the top row and then across the bottom row, and your answer is a fraction. So 2 divided by 2 is 1. 8 divided by 2 is 4. So in this problem, we went from 2/8 back to 1/4 by division. And in this problem, we went from 1/4 up to 2/8 by multiplication. Does that work because multiplication and division are the opposites? It does. So even in fractions, multiplication and division are opposites. All right, so to find an equivalent fraction to 6/8, Beth divided by 2 to get 4 in the denominator. What should Beth do to find the numerator? What are the equivalent fractions? All right, well, let's just start off by doing what Beth did. So Beth to find an equivalent fraction to 6/8. So let's write that first. We have 6/8. Beth divided by 2. All right. Now, we know if she's dividing by 2, it has to be on the top and the bottom, right? You have to keep it the same. So, 8 divided by 2, she got a 4 in the denominator. I think that's right. I agree with her. Now, what should she do to find the numerator? Well, she does the same thing, right? Now she just has to divide around her numerator. So 6 divided by 2 would be 3. All right, so what did she need to do? She needed to divide her numerator also by 2. So I will write that over here. She also needed to divide her numerator by 2. And my equivalent fractions, we can just circle them. 6/8 and 3/4 are equivalent. All right, at this point you might be realizing that you can not only find an equivalent fraction by multiplying with the same number in the top and the bottom of another fraction, you can also do it by dividing. All right? So both will work. We're going to practice more on this new idea in a minute, but both ways will work. All right, let's do number 10 real quick. Fill in the missing numbers to find an equivalent fraction to 5/6. All right, so I'm going to rewrite it over here the way we have been doing it so you're not so confused. So 5/6 times, they had a 2 up here over something, equals 10 over something. These things mean exactly the same, okay? So I want you to become familiar with this so that you're not confused on a test or a quiz. So here's our first fraction, 5/6 times 2 over something equals 10 over something. Well, what's the number one rule? When you find an equivalent fraction, you cannot just fill this in with anything, right? It has to be the same number. So it has to be the same number. So if I have a 2 in my numerator, I need a 2 in my denominator. That is the only way this works. So 5 times 2 is 10. She's right about that. 6 times 2 is 12. So if we go back here to fill it in, this would also have to be a 2, and this was a 12. So now we know that 5/6 is equivalent to or equal to 10/12. All right, let me pause, move my screen just a second. All right, so at the bottom of our page, really quickly, before we do some whiteboard review to wrap up our lesson, we will do 2 more practice where we use the models, okay, to find equivalent fractions. So number 11 asks us to shade the model to show 2/5. So that's step number 1. Then show 10 equal parts and write the equivalent fractions. This would be number 2. Don't forget when you have more than one step. So first step, shade the model to show 2/5. It's already split up into 5 equal parts, so my denominator is taken care of. I need to show my numerator that 2 spaces have been shaded. Okay? So 2/5 is my first fraction. We can go ahead and write that here. All right, then show 10 equal parts and write the equivalent fractions. All right. Well, remember how I told you earlier, we can split, since I want 10 equal parts and I have 5, can I split all of my 5 parts in half and then have 10? I can, okay? So I'm going to use this green marker to show you splitting them in half. Okay, so now do I have 10 parts? I do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, how many parts out of 10 are shaded in? So I have to count my tenths. I have 1, 2, 3, 4. So out of 10, 4 are shaded. So that means 2/5 and 4/10 are equivalent fractions. And all that means is they are showing the same amount of the whole shaded. Okay? All right, let's try number 12. Shade the model to show 1/4. We'll do that first. Then show 12 equal parts and write the equivalent fractions. All right, well, let's go ahead and shade to show 1/4 first. So there are 4 equal parts. I need to shade one of them. All right, got that done. So my first fraction I showed is 1/4. So now they want us to show 12 equal parts. So right now I only have 4 spaces. How could I divide those 4 spaces so that I have 12 parts? What if each space was split up into 3 pieces? Is 3 times 4, 12? So that'll work. Okay, so very carefully, do your best. Each of your spaces has to be split up into 3. Okay, so that we have 12 parts. So 1, 2. So I have 3 spaces in there, right? 1, 2, 1, 2, 1, 2. And now I have to count how many spaces I've got. Let's make sure I did it right. I should have 12 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my denominator is 12. And now to find my numerator, I just look and see out of my 12 spaces how many are shaded. 1, 2, 3. That's it. So 3 is my numerator. And I know that 1/4 is equivalent to or equal to 3/12. They show the same part of the whole. Okay. So as I said earlier, I am going to want to do just a little bit more practice with you. So while we're still on this problem, we're going to go ahead and find another equivalent fraction for 1/4, doing it a different way, okay? So off to the side here, write with me 1/4 times something over something. So for now, just draw your fraction bar, equals something over something. Okay, just start there. All right. I need you to come up with an equivalent fraction to 1/4. So we'll do this one all together. Remember, you can pick any number you want. So I'm just going to go ahead and do 2, okay? 2 is always one that works. So I'm going to multiply 1/4 by 2 over 2. And let's see what we get. 1 times 2 is 2. 4 times 2 is 8. So if I had asked you to find an equivalent fraction to 1/4, we can say 1/4 is equivalent to 2/8, right? All right, let's try another one. I want a different equivalent fraction for 1/4. So this time we're still going to set it up the same. But this time we can't use 2's. We already used 2's. If we did that again, we would get the same equivalent fraction, but I want a different one. Why don't we try 5? Okay, 5 over 5. Let's see what we get. 1 times 5 is 5. 4 times 5 is 20. All right, so we have another set of equivalent fractions. 1/4 is equivalent to 5/20. So I'm telling you guys, you can literally pick any number in the world other than 1 and get as many equivalent fractions as you want, okay? So you can keep going. If I said find 5 different equivalent fractions for 1/4, you would want to do this 5 different times, each time using different numbers, right? Okay, so I also told you that we would practice the division way. So we will practice that right over here real quick. This way, I will be honest, for now is not quite as important, but it is still quite important for your future. So we're still going to practice. So usually division happens when you have a number other than 1 in your numerator. So let's just use the fraction 6/8. Okay, so everyone write that down wherever you have space or on your whiteboard. And if I said, find an equivalent fraction for 6/8, we could do it this way. I could say, all right, I know how to do this. I'm going to multiply it by 2 over 2. That works every time. 6 times 2 is 12. And 8 times 2 is 16. So there are my equivalent fractions. And that is perfectly fine. But what if I wanted an equivalent fraction that had numbers that were smaller than 6/8? Okay, if you multiply, you're always going to get a larger number. So let me show you how you can use division to find equivalent fractions. So I'll rewrite my 6/8, and I'm going to divide by something. Now here's the problem with division. I have to make sure that the number I'm choosing to divide by is a factor for both of my numbers. So like, think about this. If I put 3 over 3 here, let's think how that would work. If I have 3/3, 6 divided by 3 is 2. 8 divided by 3, ugh, that doesn't come out even, right? So 3's not going to work for this. So when you're using division, you just have to make sure that you are able to divide your numbers by the number you select. So I'm trying to think of a common factor that these both share. And I know that 2 is going to work, right? They're both even numbers, so I can divide them by 2. So let's try it. Let's divide 6/8 by 2 over 2. 6 divided by 2 is 3. That'll work. 8 divided by 2 is 4. Okay? So, in the same way that you can find an equivalent fraction by multiplying, when you have a number that's bigger than 1 like this in your numerator, sometimes you can divide by a fraction with the same top and bottom to get an equivalent fraction. So 6/8 is equivalent to, or the same as, 3/4. All right, so your practice today, you're going to do some stuff like this, okay, where you're multiplying to get equivalent fractions, and you're going to try a couple problems like this. It is on Teacher Made, so you'll be able to draw out boxes and make lines. Do your best. These types of assignments oftentimes are graded based on effort. So just do your best on the assignment, and tomorrow we'll keep working on fractions. All right? Have a great day. I will see you later.